Morning, sir.
Good morning.
Sir.
Okay, before we start, I have one announcement to make. Next week, Thursday, is Christmas Eve. So our KPP asked us not to have class on that day lah. So I'm going to cancel next week class. So your next lab 4 presentation, we do it another week lah.
Okay, sir.
Okay, sir. Okay.
So that you guys can enjoy more. Okay. Alright.
Thank you, sir.
For your video, are you doing anything on the orifice and rotameter? I mean, do you do the actual lab demonstration on it?
I do the orifice and the venturi.
Okay, then just show me the orifice. Enough. Demonstration. Don't show the theory. Yeah, don't show the theory.
Okay.
Your video you like to start the lab, okay, of orifice.
Okay.
You share the record?
Dah.
Video kan?
Ya, kau tahu kan part mana?
Sekejap.
Wait, sir. Part yang repeat the step for orifice tu?
Cute.
Mute, guys. Mute.
No. This one is for the venturimeter. This one. This one, sir.
This is the venturimeter.
No, kan the one with the plate. This part with the plastic one is the orifice.
The one in the middle got plate kah?
Yes,
What plate it is?
orifice plate.
How do you make that orifice plate?
I use the laminating paper, hard plastic, and then I put the
Plastic and you drill a hole.
yes.
Okay, but then you just let the water pass through like that.
Yes,
You
because
don't have
the
any
straw,
manometer.
the straw is at in front.
Oh, okay. Can you show that again?
Belakang iklan. This one, after and this one.
But this one is too far away already lah from the orifice.
Oh,
How much difference in the height of the water?
very high.
Difference got large difference kah?
Yes, because the hole is very small.
Oh, okay. got the video, can show that? Never mind, you play this part again.
Oh, okay.
Yeah, just play it. Okay, on the left one got label kah? The left one very low one.
Yes,
Do you know why the left one very low?
because it's too far.
No, because the water level is not rising high enough.
Yes.
Yeah lah, you have to fill up the whole pipe. Only then you can use the manometer. That's why on the left part it don't have anything, and on the right part, it's already too far from the orifice. It already, I would say, it's already like sort of stabilized at certain point already lah. So it doesn't matter. You got do is good enough already, and then the conceptual of the orifice in the middle using plastic is correct Okay, just that the tubing location is not that correct lah. Especially for the first one, it's too near the entrance already. So and then the water level in the bottle is not high enough.
Oh.
Okay. So the mistake of the lab demonstration is there lah. Okay. All right. So Clarissa, what is the concept of the orifice that you can use it to measure flow rate?
What, sir?
for an orifice, why you can use it to measure flow rate, or how it can be. What's the reason that we can use orifice to measure flow rate, or what is the principle behind?
We use the orifice so that the pressure drop.
And then
the flow rate will increase. From there, we will calculate it.
flow rate will increase. You measure flow rate kan, bukan flow rate will increase kan?
Huh?
You are measuring flow rate, but why flow rate will increase?
Because it has small entering area.
Okay, I help you to rephrase. When the water pass through orifice that has a small hole, the pressure drop is very significant. So we measure the water level in the manometer before and after the orifice. Then we can have the difference in height. And that difference in height, we can use Bernoulli equation or certain equation to measure to calculate the flow rate.
Yeah.
Okay.
Okay.
Marina, what is the principle that again? Why we can use rotameter to measure flow rate?
Wait. Rotameter. Because it has simplistic operation whereby a liquid or gas pass through the tap tube.
So when the gas passes through the tube, it will
So the flow rate is high.
when the flow rate is high, what will happen? When the flow rate is high, the flow will go upward.
Yes.
Then how?
Then the water height is increased.
Rotameter don't have the manometer like others. Rotameter don't have. Rotameter don't have the manometer, don't have the small tube that you got the color water to show it the height of the water. Rotameter don't have. The rotameter has a float that when you water pass through, it will push the float upward, but because of the float is quite heavy, so the gravity will pull it down. So these two forces, they will be like equalized or stabilized or in an equilibrium, okay, or steady. So it will stop at one place, and each place is according to the flow rate. So we can draw a scale there. So the next time we know, when we measure other flow rate, then we will know what is the flow rate.
Oh, okay, sir.
All right. Okay. So can you go to the data presentation? Data. Who is presenting? Michelle is presenting, kah? I cannot hear anything.
Yes. Okay. Hello.
Can you present?
Okay. For the demonstration of the operation and characteristic of the three basic types of flow meter. This is the manometer reading for the rotameter, venturi, and orifice. Next, Claire. This is the sample calculation for the venturi flow. By using this equation, we can get the flow rate.
Okay, so for the venturi meter flow rate, the equation, I noticed that got HA and HC. Michelle, can you tell me where is that A and C?
HA and HC is the part where the manometer reading at A, which is at the inlet of the venturi meter. And then the HC is at the throat of the venturi meter.
Okay, correct. Next one. Next slide.
Okay, for the next slide is this is the flow rate for the orifice plate, and the flow rate is 15.17 liter per minute.
Okay, so Daniel, can you go back to the previous slide? So in the orifice calculation got HG and H. I want to know that G and H, where is the location?
After the orifice, the plate, after the plate. Is it? Manometer.
Got G and H, got two locations. One is after the plate, another one?
Before the plate.
Okay, so G is inlet, H is the outlet.
Yes, sir.
Outlet, or actually the orifice, they call the small pore orifice, I think. So after the orifice now. Okay, next slide. Okay, present.
Okay, this is the determination of the loss coefficient when fluid flows through 19 degree above. This is the volume, and this is the time, the flow rate, differential piezometer head, V, and V square over 2G. So this is the graph for the piezometric head versus velocity head. And then from this graph, we can get the slope. Slope K is equals to 0.963. To calculate the Q, to calculate the V square over 2G, we get the V square from the before slide. We get the V from this part, the velocity, and then divide by 2 times 9.81, and then we get 3.28 millimeter.
Okay, Marina, what is that 3.28 mm? Is it some kind of diameter? Marina, you think about it, can you go back? Okay, Clarissa, what is the purpose of this part of the experiment?
The purpose to determine the coefficients of velocity and discharge of the orifice in the lab.
Discharge coefficient, CD?
Coefficients of velocity.
What is that coefficient of velocity? V square divide by 2G kah? Okay, so Marina has to answer the question first. V2 divided by 2G. Do you have answer, Marina?
The height of the float.
No. Okay, the V2 divided by 2G, 3.28 is actually the velocity height. If you look at the diagram, you look at the figure, the x-axis level is called velocity head. So I guess velocity head is not called velocity coefficient. So this purpose is not to find velocity coefficient or velocity head, because you still plot the graph kan? So you plot the graph, you want to do what, Clarissa? What is the purpose of the whole thing? Others can help? Others?
Purpose.
Or what is the objective lah? Objective. You go look at the title at the data there. Should have data, the table. Should have a title then. Not this
To
one.
demonstrate.
Not this one. Not this one. Next one. Next one. This one. What is the title?
Determination of the loss coefficient when fluid flows through a 90-degree elbow.
So we want to find loss coefficient. So tell me, Daniel, what is the loss coefficient in this experiment?
The loss coefficient. The slope, sir.
Yes.
The slope.
What's the number? What is the number?
0.963.
Okay. Okay. You are right. Correct. Okay. So this objective to find loss coefficient, K value equals to 0. something. But the your senior or someone do this data is wrongly taking the slope. Go to the graph there. It's wrongly taking the slope. You notice that he is taking the R square as the slope. The R square is not the slope. R square is the correlation coefficient of the line of the data. So it is something statistical. The slope of the line should be what value, Michelle?
The value should be 0.1011.
Yes, okay. So the value should be 0.1011. Okay, not the 963, no,
Yes.
because someone else did the mistake.
Okay.
All right, that's it. So next week, no class. So enjoy the Christmas holiday, and then please upload the video to the link, upload the link and check your attendance.
Okay, sir.
Oh, okay, sir. Okay, thank you, sir.
Merry Christmas in advance, sir.
Merry Christmas.
Merry Christmas, sir.
Christmas.
Bye bye.
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 Bye.